Welcome, I'm Alan Higgins. This episode is a presentation by Stefan Helfrich from KNIME, spelled K-N-I-M-E, a company that builds software for the entire data science lifecycle. Stefan explains and demonstrates how to teach data analytics using KNIME's visual workflows approach. Our hosts are Christina Phillips and Anabella da Silva Felipe Suarez.
Hello everyone, thank you for coming. Today we're very privileged to have Stefan Helfrich. Have I pronounced that correctly, Stefan? Helfrich. It's the foot in the middle that throws me out, yeah. Stefan Helfrich, who's from KNIME, and he's offered to come and show us how to incorporate workflows into our teaching with business analytics. I'm really looking forward to this because I often teach students who are not great at statistics and analytics and quite often find a spreadsheet pretty hard. And actually this sort of teaching is a way to make the more higher level analytics work more accessible to students like that. So I'm really hoping to have some takeaways from today.
Thank you, Christina, for the warm welcome. So I want to talk about teaching, analytics or data skills in general with your workflows and in particular with KNIME. A couple of words about myself. Christina already mentioned that I'm responsible for academic relations here at KNIME, have been for a couple of years now. My background actually is not in business analytics, but more the life sciences. So I have an undergraduate degree in bioinformatics and then gradually moved more towards the computer science side, did a lot of biological systems modeling, computer vision during my PhD as well. And that's also when I started using KNIME. Couple of words about us as a company, because KNIME actually is backed by a company. We are a software company, started out roughly, next year, 2 decades ago. So not a new player on the market. We've grown to roughly 250 employees these days. I think I joined at number 40 or something like that. Office in Europe, headquarter in Zurich, Switzerland. So when I say we build software, what I mean with that, and that's an official slide, I'll show that to get that out of the way. We build software for what we call the entire data science lifecycle. You could probably call that data lifecycle or whatever you want to call that. So the idea really is that KNIME has the software that covers everything from getting your data into the platform, blending data from different data sources, modeling, visualizing, exploratory data analysis. So that's more the left-hand side, what we call the creation side, basically building, setting up your analysis. But then there's also software for the productionization of these, what we call workflow, or more general of analysis that you're building. I will really today focus very much on the left-hand side, the analytics platform. Why is that? You'll see that in a second, because the analytics platform really is what you use to build workflows. And that's what I want to show you today and convince you that it's actually a good idea to use it in teaching. But also, really, disclaimer, KNIME Hub is a commercial software. We are a software company. This is basically how we make our money. I just wanted to get that out of the way as well, right? We are a company, we built an open source product, but then there's also the commercial counterpart that you can use to productionize data science workflows, basically, and that's what you pay for in the end. So questions I want to answer today in the next, hopefully something like 45, 50 minutes. We'll see. Again, interrupt me at any time if you're curious. Why you would be interested in using visual workflows for teaching, business analytics, data analytics, or data skills in general. And I know at least Christina is already hyped about that. Why you might be interested in using KNIME for that, integrated into your teaching. And then also a slight aspect on if you're interested, if you're doing research, can you use KNIME for that aspect? So where do we start? Teaching data, and for instance, I teach regularly a module on marketing analytics or data analytics in marketing, for instance. So teaching data topics is by itself hard enough, right? The learners need to learn about, they need to gather technical knowledge, right? Stats, data engineering, machine learning algorithms, but also soft skills, right? Business analytics, interpreting charts, building useful dashboards that others can derive or make decisions based on. So this is in itself already, it is tough. Very often people do make the switch and maybe put a bit the conceptual and the concepts and theory in the background in favor of hands-on experience. And I totally understand that. I am more leaning towards the let's focus on the concepts and maybe a little less on the tool side, but that's just my personal opinion. And really, because data is generated, well, almost everywhere, right? You're business analytics educators, but there's psychologists, sociologists, biologists, economists, like everyone is working with data these days, right? So typically, at least in my case, also very often we end up teaching a heterogeneous group of students. They are often domain experts, but they don't have a classical programming background, right? So I think the goal probably should be right, striking the right balance between the concepts, but also giving them tools that they can easily be onboarded on, that they can start using easily, ideally also being able to use those tools later when they graduate, right? And I have one slide. Michael, our CEO, he's not a professor anymore. He used to be professor of information mining and bioinformatics. He wrote actually a couple of years, well, it's 2025, so it's 6 years ago. He actually wrote an article, what does it take to be a successful data scientist, way back when. And he was arguing in that, right, is data, working with data or data science, what it was called back then still, is it something, do you study for that, or is it more an apprenticeship, right? He argued that, well, it's both, because you can't apply the methods if you don't understand them. Also, if you don't understand the concept, you can't really sanity check the results without the real world experience. And the funny thing is, now that I say that, it's very these days when it comes to large language models as well, right? You need to understand things, you need to be able to sanity check and verify. So that was already true in my opinion a couple of years back. And also back then, a lot of data science programs required people to go through a programming course in their first term. And we actually think, well, this doesn't have to be the case. There's great tools out there that let you circumvent the coding, and great concepts like visual workflow that allow you to get around that coding, or at least ease the burden in the beginning for the learners. And if they want to tap into that potential of coding, we might still want to let them do that, right? So that's why we heavily advocate for visual workflows in really an integrative and an open platform, where the ideas, and I've had that really just as a very blunt comparison here on the slide, Python script or whatever scripts, could be an R script as well, versus the same thing in a visual workflow, right? And hopefully it's immediately clear that in a visual workflow, you immediately see how the data flows, basically, right? While in code, it's a sequence, typically a sequence of steps, basically. So that's kind of hard to follow, right? So visual workflows are a great tool for teaching. That's, I think, a general scheme, and that does not only apply to KNIME. But with the KNIME Analytics platform, what we actually bring to the table is that it's a tool that's open source and free, that implements the visual workflow or a visual programming paradigm, so that the students can, or the learners and yourself also in research, you can do and run analysis without having to code. But if you want to code, I'll get back to that very briefly later on, you can actually do that if you want to, right? So
Stefan, I was just going to ask, can you, each one of these a little block of code that you could actually access if you wanted to?
yes. So what we can do, and I'll start just getting the language straight a bit. So what do we talk about? We talk about nodes in the KNIME universe. That's the yellow or multicolored rectangles, basically. Nodes perform, or a node performs a single operation, like a table splitter, as the name suggests. It takes a table and splits the table into two. We have input ports on our nodes, basically determining what data that node executes this operation on, and we have the output ports. That's basically the results of the operation. There can also be nodes with no input ports, multiple input ports, no output ports, multiple output ports. Really heavily depends on what the node actually does. So coming back to your question, Christina, the nodes are implemented in Java. That's still true for, I would say, like 97% of the nodes. Since KNIME is open source, you can also dig into the source code and see what actually is executed once a node runs or executes its particular operation. So taking these nodes, we can combine them into so-called workflows, right? And we basically string together, and you'll see that I'll show a live demo in a second. You basically string together nodes to build such a workflow. Like it feels a bit stupid to bring that up, but it's thinking about Lego blocks, right? Lego blocks, and you have individual Lego blocks being one pieces, and you can put them together to build a castle or a car, whatever you're basically building. And that's the idea behind the KNIME workflow as well. And for us, the interesting part is that these output ports and input ports, by connecting them, you basically model the data flow. So I think a great thing already here is that without like telling someone, these are the basics. Hey, if you see block yellow or orange, that's one operation. The arrows and the black triangles is how the data flows. People can start reading workflows and at least on a high level understand what a workflow is doing. So as the title of that slide hints at, there's not only nodes and workflows, but there are also, and that's where it gets interesting, there's so-called components and meta nodes. So one thing, just a comparison, because some of you might have used other visual workflow tools, basically, KNIME workflows are pretty verbose by comparison. That is, a node does actually executes a very specific operation, like filter rows from our data according to some criterion, and then remove the columns and then remove duplicates. It's not like there's one node that just automatically does pre-processing of data, for instance. The interesting part when it comes to teaching here, though, is that you can wrap nodes into these so-called components or meta nodes, right? And this helps with hiding complexity. And you're basically, if you're here with the left-hand side, we have a couple of nodes. We can take them and wrap them into a so-called component. And then again, using piggybacking of your question, Christina, here in that case, these nodes, they look very much like a KNIME node, but then what's basically run, what's executed is not an implementation that we provide, but it's actually what we see here on the left-hand side, the sub workflow basically. So that's actually nice in teaching because you can build your workflows in such a way that they, for instance, look something like that. Very, very high level, really. You have a reader node, you read the data, you do something, you calculate overdue invoices or whatever. It's hidden behind a component, but as soon as you open up the component, and that's, I think, for teaching, that's actually the beautiful thing, is that you can open up these components and see what's happening inside of that, and you can really dive deeper into that. And that's also very often how I teach concepts, that I start showing people, hey, this is the general workflow that we have, and then we can dive deeper into individual bits and pieces depending on what the focus of the class, for instance, is. And you can really also just say, well, I will focus on this component, but not on another one, for instance. And these are also these components, you can build them yourself, but they can also be shared. We are providing them, the community is providing them. You can also use them like regular KNIME nodes, like it's a bit of workflow, sub workflow component, and so on. So that's actually, for teaching, in my opinion, very, very powerful, but also why we say, well, it's visual programming and it's pretty fine granular, actually. So there's in a base KNIME installation, there's over 2,000 nodes included. If you add a couple of more extensions provided by us or by the community, that adds up to over, I think, over 4,000 nodes at this point, really covering everything from, and I'm just picking examples here, from accessing data from an Excel file or a CSV file, probably the most straightforward thing. But these files can not only live on the hard disk, but you can get them from Box, from a share drive, immediately directly in your workflow, basically. Transforming data, cleaning up, analyzing everything from descriptive statistics to building predictive models, linear regression, classifications, these type of things. Visualizations, obviously, we have the most common visualizations, scatter plots, line charts that you can think of. Then last but not least, deployment. I'll not talk too much about that, but just want to bring that up. you can also prepare data in KNIME and send that to Tableau, for instance, for visualization, or integrate it with Power BI. That's a typical use case that we see a lot in teaching, where people say, well, I already teach Power BI or Tableau, for instance, but I want more functionality, and then they start slowly adapting KNIME, basically. And interestingly, at this point, up until this point, I haven't really talked much about use cases and what type of data you can work with KNIME. And that was a very deliberate choice, because KNIME is a generic platform, right? You can think of KNIME as it is a programming language like R or Python, well, plus the user interface on top of it, but it doesn't really matter where the data comes from, right? So you can cover everything finance related use case, more in the automation side of things, monthly reportings. Seagate, for instance, does end of line testing, just as an example. They do a bit of image processing as well. You can work with unstructured data, texts, just as an example, and you can work with that as well. And I will also show you an example in a second that you can also work with geospatial data. That's one of the more advanced examples that I want to show you today. All right, so this is what the analytics platform looks like. So look towards my second screen actually a bit more. It's at this point pretty intuitive to use. What I have disabled is you'll get like product infos the first time you started. Click here to create a new workflow, click this and so on. So there's a bit of guidance for new users as well. But what I want to show you also is that KNIME already comes with some example workflows up here, and I'll open that up to give you some idea of what that looks like really in practice. So we have our workflow editor here, the main screen basically, tabs up here with multiple workflows that you could be working on in parallel or demoing as a lecturer basically. Tabs on the side here, info with descriptions of the workflows that you're building, it's an example workflow, but also descriptions for nodes if you're selecting them, right? What does the node do? Options, configuration options, and so on, right? So to give you an idea, and really one thing that I find very intuitive about and really great about KNIME is that, first of all, if we use an example workflow here, loads of example workflows, they come with data, so I can immediately execute a node. So here, this node hasn't been executed. There's a play button. Watch the small traffic light below the node. I hit it. It's a bit of a progress bar below it, jumps to green, meaning, okay, the node has executed its operation. And the great thing really is that immediately once a node has been executed, you see the output that is available at the output port, the table basically. Right? And I can do that for all the nodes. You can go in, execute the nodes. You can really easily switch between nodes and immediately also see the results of an operation. And this for teaching, I find that very, very helpful, because you can easily do a like before after comparison of what a node actually does. You also get, when it comes to explaining operations like column filtering, removing columns, basically, you also get the information up here. Hey, there's so and so many rows and columns in a table. Switch over to the column filter, check 8 rows, 2 columns instead of 3 rows. So 1 column obviously has been removed. I mean, I would have guessed that from the output table as well. But if there's more columns, this is actually a nice overview. So you can really immediately get an initial understanding of what the data looks like, how it actually is structured. And then the second thing is you can not only take a look at the data, you can also switch over here to the statistics tab, and then immediately get information like how many missing values do I have in my data? How many unique values are in a column? Minimum, maximum, really descriptive statistics. Something that is really at a fingertip. You click on it, and then you get that information basically, right? So that is one of really the major points that helped me a lot with teaching, and that students actually come back. They really can easily look at the data. So on top of that, I mean, I started with an example workflow. Let me show you how that also looks like, how you add nodes basically. So we have here in the side panel, we have a node repository. This is really all the nodes that are available in a KNIME installation. They differ depending on what type of extension you have installed and so on. But there's, you can browse that, look at the IO category basically, maybe switch that over to a tree view. And then you can immediately see there's a lot of reader, writer nodes to get your data in, data out, Google Sheets, Excel reader, and so on to really easily load your data and get your data into the platform. So one thing that happens, and I'll just show that for comparison, I'll just drag and drop an Excel reader over here just to add that to the workflow canvas so that you see how that looks like. What you'll see is that the status light actually is red down here, which means, well, that node can't execute its operation. Why? Easily always hover over that, see there's a warning sign. Well, please specify a file. Why? Because we only said, well, hey, there's read an Excel file, but not which Excel file, basically. So how do we do that? In the life cycle of a node, typically add a node first. Then there's this small cogwheel up here. If I hover over, it says configure. That basically opens up a configuration dialog where you, that looks slightly different for every node, but most of the nodes have a configuration dialog. In our case, we basically have to specify up here input location for local file system, for instance. I can hit the browse button and to move it over, hit the browse button basically, and then I can select the file that I want to read, right? And I would then immediately get a preview of my table down here. Actually do that for the fun of it. Just load an Excel file, some sample data that also comes with KNIME that you can immediately get a preview down here. You can define data area. If you want to skip some rows, only want to read A to Z, 25 to 100, these rows, you can all set that in the configuration dialog. And once you've done that, then you see node jumps over red to yellow. It's actually configured, has all its operation, all its parameters. You can hit the execute button, and then only then also will the data be available at the bottom. This also goes a bit quicker if you want to. You can also just drag and drop data like from an output port, basically saying, well, I take the data and want to do something with it, can let go of it somewhere, and then I can add a new node in that, and by that, successively one after the other, I can basically build my workflow. And if you're into that, and that's one way where we actually have added AI as well, basically doing smart suggestions of what could be the next node, but also saying, hey, this is what I want to do. I don't know what the node is called to do that, though. Like I want to remove rows, because then I don't have to know what a row, like what the node is called a row filter, basically, right? And that can provide that in natural language. And this is actually really helpful to learners in the beginning. In that case, it doesn't hallucinate. It's a trained model. It only really returns nodes that are available, so students don't fall into that trap either. Really great thing, trained on our documentation and the example workflows that we have as well. So this, I think, really is a nice co-pilot use case where AI really works well. Does this make sense so far? Do we have any questions?
I would have one, wouldn't I? So can that help you with things like, I'm thinking of Ultrix here because I was quite a heavy Ultrix user at one point. Would that tell me, how what syntax I use for an if then else on this column, or what regex do I need here, or can you write me the regex to do this, or stuff like that? Will it do that kind of thing?
So in this case here, what we have on the screen, this will insert nodes and it will configure the nodes for you. So if you say something, what did I actually read? I need a column name. Let's do that just to give it a try. As I said, I wanted interactive, so let's do that. I can see my data. Let's say we have international mins here. So let's drop all the ones with international mins less than 10. Let's try that. I need to log into my KNIME Hub account because it's free. You can create that, and because we host the model basically. Remove all rows with intel mins less than 10. Let's see. We do it live, so I don't actually know if this works. So we have a row filter.
It looks like
you
it.
Open the configuration dialog, it automatically adds this and says, well, filter column. That's what the feature we filter on, international minutes, greater than or equal 10. And we filter behavior. We keep the ones that match the output, right? That's why it says greater than. So can run that. And again, I can immediately see, well, statistics, we use that, international minutes, minimum 10. So it did exactly what we wanted it to
Excellent.
do. Yeah. So this is
Nice.
really powerful also for people for learners to get started, because one of the initial hurdles really is I know what I want to do theoretically, but I don't know which node to use, and this really helps tremendously with that hurdle. That's really what I want to show, to give you really just a bit of a look and feel how KNIME behaves. There's a lot of learning materials with self-paced courses, e-learning courses that either you yourself or your learners can also take. They're all for free. We've received great feedback for them. So very often we actually lecturers end up in a situation where they say, well, I'll focus on concepts in my class, but then you do go and do the self-paced course by KNIME to onboard yourself at your own pace to the software. This is really working tremendously well. So having said that, I brought a little use case that we built for a European institution on crime statistics. So what's the use case? We want to visualize, because the visualization aspect is always very important, and visualize crime numbers by different crime types, different European countries, and maybe even down to the state level. And we want to set them in relation to each city or country's population, right? By a number of crimes committed by 100,000 population, for example. And then we really want to put that into a nice visualization, something that really then looks like this, where to really look at the city level as well, select which, here on the left-hand side, select which type of crime you want to investigate, some more visualization at the bottom, and really dive dive a little deeper into that. So the data, and I think that really is the interesting part, and that's also why I picked this as an example. So the first two data sources are quite straightforward, I would say. If you want to work with crime, we need crime numbers, ideally annually, ideally by country and down to the city level, right? So there's Eurostat as a good source for that on the country level, and for some metropolitan areas, that data is available. Very easy to get that into KNIME. They already provided as CSV files, if I'm not mistaken. So you can just download them, really drag and drop them into a KNIME workflow and start working with that population data, because we want to normalize it to the population. Again, we can get that information from Eurostat, again, country level, but also the metropolitan areas, data available up until very recently. And then the last part is actually pretty interesting, because we could already do things with the first two data sources. We can also add some geospatial data to that, right? We can have city coordinates, latitude, longitude, for instance, from something like OpenStreetMap, and then really put the data that we have onto the map and have that interactive in the visualization. And this is also why I picked this as an example, because the geospatial data is a good example for the flexibility of KNIME, right? It's ease of use on the one hand, but then also being able to work with images, geospatial data, you name it, basically. So for the geospatial data, we're very often, we're probably preaching to the choir as well. You're working with polygons, maybe points, individual points, lines. All of those we actually put into our tabular structure. So we still work with tables by introducing a new column type. Typically that's strings, numbers, but now there's also a geometry type, basically. So every cell in a column of the geometry type can be a point or multi-points, can be polygons, and we can really process them in typical KNIME fashion, basically, right? So how would I do that? Just to give you an example, so there is an OpenStreetMap boundary map node, just as an example. You can interactively, in its configuration dialog, you can provide the place name for which you want to get the geometry, Cambridge, Massachusetts, in the US, for instance. You configure that, hit the OK button, and what you'll get in the output is a new column with a polygon that shows the city limits of Cambridge, Massachusetts, as an example, right? And this really also shows the flexibility of KNIME with respect to the data types. And to give you an example of that, this is also more on the upper end of the complexity of a workflow, where I say, well, it's not just for the educational setting, but you can also use it for your research. And I'll show you that concept that I mentioned earlier, because this is a workflow. I had that on the screen. You can download that workflow with central place, for example, workflows or community hub. You can really download that workflow, inspect it yourself. They all come with sample data if they are from us and not from the community. And then you can really dive in and open these meta nodes here, for instance. You can control, double click, and then you dive really into that, and you can take a look what's actually behind that black box, which, well, we call them gray boxes basically. And then up here, get breadcrumbs. You can zoom out again to the next higher level. If this is not of interest to your class, well, students can just execute it and be done with it. Or if you want to really highlight that, you can open it up and explain that basically, right? And that really is a workflow that you can build, and also to show you the visualizations basically. So this is, for instance, what it looks like. There's interactivity here. I can zoom in, hover over, see those data points, can actually switch between. That will take a second, but it's actually quite didactic. So I can switch from robbery to assault, for instance. And you'll see there's a bit of a progress bar happening, because what actually happens is this is not only on the visualization side, that this actually reruns everything basically that we have inside of this component here and recomputes things, right? So even these interactive visualizations, you really get the full flexibility of a KNIME workflow, and it's not just a slightly different view of the same data that you have been generated. So you could do interesting things like even build models and visualize the outputs directly, or something like that. And this really opens up the door to using KNIME in research. I don't have very many slides about this, and it's hard to keep track of what people use KNIME for to do their research. If you're curious about that, pick, I don't know, go doing a request to OpenAlex or Google Scholar, or your favorite tool where you go looking for papers, basically search for KNIME. What you will see is that that we're pretty strong in the life sciences, because that's also where we came from. So the first lines of code were basically sponsored by the pharma industry way back when, but this has really spread out. Here, for instance, geospatial analytics, we have a lot of that. Medicinal and computational chemistry is what I mentioned before. Intrusion detection, cybersecurity, telecommunications, marketing analytics, these type of things. There's basically not really a limit on what you can build with KNIME workflows. And just to zoom out a little, why this works so well with KNIME and visual workflows in general, because anyone can take a workflow that you're building, even without coding. They can, to some extent, understand what's going on, so you can focus on the method and not really the implementation of the code. You automatically automate things, right? But that's the same for in Python script or an R script. The KNIME workflow, it's open source. You can share KNIME workflows. You can send them to someone. You can put them on Community Hub, link to them in a paper. Basically, people can download it and execute it for free. So also the reproducibility and repeatability is a huge thing, and really part of that is also at the community hub, basically, so you can easily upload your workflows and share them with the wider community. And they can easily drag and drop these workflows into the analytics platform. If you want to, you can also export them into files and put them into your GitHub repository. But don't tell anyone that I told you that, because it's possible, but it's not merely as easy for people to get hold of that workflow and use it in their own analytics platform. And you can really tap into the full potential here. Just pick the machine learning example, supervised, unsupervised algorithms, clustering, linear regression classification, various models, even deep learning. And these days, I should actually put that on this slide here as well, integrations with large language models, basically making prompts to large language model part of an analytics workflow, where you don't completely rely on, hey, here's everything that I have, LLM, please, this is what I want to do, return me the result. But it could be very specific, and you can do parts, I don't know, do outlier detection in KNIME, or build a model, get a prediction, and just get an interpretation from a large language model. So workflows are really open. KNIME offers a lot here, so not just in teaching, but also in research. And the part also to answer your question a bit more, Christina, that you mentioned before, does the AI assistant help me with writing if switches, whatever? It also does help you with Python scripts, for instance. So we have in our AI model, we can integrate Python scripts into your KNIME workflow. It basically looks like it's a regular KNIME node. You hit the configuration dialog. That's what you see here. You basically provide your Python script, and then that's actually what gets executed when you run that node. And here it's a bit hard to read probably on the slide. Here it says ask Kai. That again, same story, opens up a dialog, and in natural language you can provide what you actually want to do, and it will generate Python code for you. Again, same disclaimer, it's a large language model. It tends to hallucinate at some at points. So again, you need to be a bit more careful. But as a starting point, it's a good starting point, but you need to make sure that that it actually did the right thing. Awesome. So that was really going from, okay, KNIME is actually great to, it's easy to get started for an educational setting, but also there's a really plethora of functionality. So we can also use KNIME in your research, but also your students if you're supervising thesis projects, for instance. A lot of students, if once they have heard about KNIME in a class, they will approach professors if they are interested in supervising a thesis that will be built with KNIME. We've heard that a lot of times already, and people really enjoy the platform and do a lot of research in that as well. Any questions?
Yeah, I have been itching to use
I'm
KNIME
not
for
done
years.
yet.
Oh, okay. So I have to say I have been itching to use this platform for quite a few years. From your perspective, as somebody who is, you're a researcher, you've come at this as a researcher, but you're also somebody who codes because, you had to do that with the kind of research you were doing.
Yeah.
If you were teaching students, say, I'm going to be sort of setting up a business analytics master's program, and I would like them to understand the basics of coding. I think it's important to understand coding because otherwise you can't clear it up when it gets it wrong. You don't know when it's hallucinating, and you don't know how to deal with it when it hallucinates. But where would you say the steps were here? I mean, would be kind of like, let's get a core concepts in computing sorted and let's go straight into this, get the AI to write the code for you environment and then learn how to debug it? Or, which switch would you do? Which way around? And I know that's a really out there question, and I don't, you're not an education expert or a computer science expert. But
It is an interesting question. As you said, it's also a pretty philosophical question, to be honest. So I'll approach it from two sides. One, first of all, is that I would argue that with KNIME workflows, and since they're so fine granular, you can actually get the learners into a programming mindset. And I'll quickly open the analytics platform just to give you an idea. I mean, the workflows that we're talking about here. This is built all around data, right? But if you open up the very first meta node already, what you'll see here, and I've spared that out, what we see here are programming concepts. Red lines are actually flow variables, right? These are variables that get passed along the data flow, basically. We have loop start and a loop end in here. So that's our implementation of these two nodes will be looped over and repeated several times. So I think it's actually starting with a KNIME workflow and getting them into look, this is how you work with data. There's control structures, there's loops, there's switches when decisions are basically being made. This is something that you can also teach with workflows, but that only gets you so far, I would say. So at that point, really, it's probably then at that point that we say, well, you've seen how like a loop looks in KNIME probably. Let's look at how that actually gets implemented in Python, for instance. Maybe you can use an LLM to start generating some code to and show them how that looks like. But at some point, the perspective probably of a learner also needs to switch to the point where they say, well, maybe I like coding. And if that's the case, I can also stick with workflows and I can embed with the Python script node, for instance. I can build a workflow that, I don't know, maybe I do the data wrangling in KNIME because it's just more natural to do that. And
Or
then
intuitive, yeah.
the more advanced stuff, maybe then I can write a Python script. And the good thing actually is that that's coming back to the idea of these components. Basically, what you can do is you can wrap a Python script inside of a component. You can share that with someone. They can just drag and drop it into their workflow, use it, and never worry about that there's a Python script if it was built accordingly. They don't have to worry about what actually runs inside and that there is Python inside. Sorry, I segued a bit here,
No,
but
it makes sense because I also think that what you can do is you can actually challenge students to write a specific script which does a specific thing in a workflow. And that could be, an assessment even there that they've actually got to do that. And if it doesn't work, then they've not done it right, have they? And they've got to figure it out, yeah, which is very coding. I mean, that's a coding environment, that is, yeah.
exactly. Just to bring up the example, and we see that a lot in teaching as well, where where educators also show like Python and KNIME in parallel. And that's actually Michael and a couple of colleagues have written a book, the textbook Guide to Intelligent Data Science. And if you look at the contents here as well, not just want to get to some examples where you can also see like we provide R code, Python code, and KNIME workflows. And this is actually quite interesting because very often, I mean, you can do the same things in these different tools, right? But some people lean more towards the visual side, others lean more to the code side. But I totally agree with you that a bit of coding just to understand, even if it's the other side, basically, even just to understand that, I think makes a lot of sense. Then I would quickly, a couple more minutes, 3 more minutes or so, because what I've talked about now, visual workflows in general, KNIME Analytics platform, in more depth. As mentioned, it's open source, free. Most of our learning materials are free and openly available. I want to add to that, me and my team, we basically support educators like yourself. So there's a program in the community we call the KNIME Educators Alliance, where we really try to support you beyond the software, right? So we try to compile things into different kits, basically for like an education kit, more for the upfront teaching. You'll get access to slides, teaching resources, more gamification kit, more on the interactive side of things. And to really just to give you an idea of what that looks like. If you join the Educators Alliance, again, free to join, and it's really on an individual level. You can hopefully decide for yourself that you join this program. You don't have to get the buy-in from the dean or whatever. You get, for instance, you get access to our teaching material repository where you get, I didn't do the math, how many hundreds or thousands of slides you get for various courses on topics from started with KNIME. You get PowerPoint slides, you get exercise workflows to specific topics, machine learning algorithms, time series analysis, text processing, you name it. For all that, you basically get slide decks, exercises, and examples, basically, that you can that you don't have to start from scratch when you want to use KNIME for these particular topics. If there's anything that's not covered, or you say, well, this sounds interesting to me, I don't have time right now to get started, but maybe you can do a guest lecture for us. Really happy to do that. I do that on a very regular basis. I mean, I'm here today. You're not students, not learners, but lecturers. But in general, we are happy to jump on calls. If it's around, we're joining live as well, and on site to talk about, do a KNIME intro, talk about specific use cases. I'm really happy to support you with that as well. So that's more on the classical teaching side. Basically, on the gamification side, what might be interesting for you is we have this program. It's called the Just KNIME It program. Basically, it runs for depending on like 2/3 of a year, basically, where we weekly release challenges so that people can try to solve that with KNIME. Come with data, a challenge description. And I'm not pitching this so that you get your students to join the Just KNIME It Challenge live, although it starts May 14, the next season, but all of them are collected, and you can also use those as exercises for your students, basically. And then, last but not least, because I had a hunch that this question might come up, there are opportunities with a lot of companies out there for your students as well. And I think with that, I'll slowly get to the end. So really, I hope that I could give you some insights on what the KNIME Analytics platform, what it feels like, why it is a great tool for teaching, because it's open source, it's free. There's a very motivated community behind the analytics platform, but also me and my team happy to support you as educators. And it's actually a tool that is not only free for educational purposes, but your learners can take it when they graduate and continue using KNIME. Building on the visual workflow approach, visual workflow a paradigm, basically, where the idea is, well, we should lower, ideally, the entry barrier or the first hurdle for learners so that they can really focus more on understanding concepts and basically try to get the tool out of the way as much as possible. And also with the crime statistics use case, just to give you an idea that it's not just an easy tool for educational purposes, and you can not only just use it for the simple stuff, but it can really also build very interesting research projects with KNIME.
Thank you for listening. This talk was recorded online on March the 24th, 2025. Don't forget to click follow and share for more.